In our last lesson, we learned about what happens whenever we add or subtract a number to the function of x squared. It moves the vertex either up or down. Today we're going to look at what happens whenever you actually put a number inside the function of x squared. Let's review what happens whenever we add something to our x squared function. We remember that when we multiply, the bigger the number is, the more narrow it gets. The smaller the number is, the more wide it gets. When we add, if you'll remember, it either moves up or down. And in this case, we're adding 1. This is our second one. We're adding 1, but it makes it be up here because we have this negative right here, which makes everything be upside down. Okay, so whenever we're adding to our function, if it's a positive number, it causes the function to move up. If it's a negative number, it causes the function to move down. Now let's look at what happens whenever we add or subtract a number inside the function. Okay, so notice this whole thing is being squared, not just x squared. So what happens here is you will see that we can, first of all, find the vertex of a parabola. What we're doing here is we're finding the g of x, which equals x minus 3 squared. And we're going to compare it to just the function of x, which is just x squared. And we're going to see how things change. So whenever we think about just this inside part, we can look at this and break it down into x minus 3 equals 0, which is x equals 3. Then we can make a table of ordered pairs and put several points in front of it. We might want to use 2, 4, any of those numbers. So let's look at this table. So in this example, they used 1, 2, 3. 3 was our number in the middle. 4, 5, 6, or 4, 5. Okay. And whenever you go through and figure those, all you're doing is everything inside the parentheses and then squaring it. We get 4, 1, 0, 1, 4. Now we need to graph that. So when we graph that, it's going to look like that. Notice it moved over 1, 2, 3 spaces. Okay. This was our original function of x squared. Our vertex is at 0, 0, and it goes up symmetrically. With our new function, it moved over to the right twice, or 3 times, I mean, and this is now our new fold line instead of the y-axis. Now, when it's inside the function, this can be deceiving. A negative moves it over to the right, a positive moves it to the left. Let's look at another example. This next example, we're looking at x plus 1 squared compared to our x squared. Okay, so x is going to equal -1, so we want to pick out a couple numbers above that and a couple numbers below that. And we need to think about the fact that this is a plus. So let's think about what we think is going to happen to our graph. Here's our table. Okay. Now, all of our y's stayed the same, but our x's are what changed. So we're going to look at this. This time it moved to the left one place because it had a +1 here inside the function. So these are called translations, when something stays exactly the same but it's moved, whether it's up, down, or side to side. This will also be a really common term in geometry. So whenever you have a graph with a plus or minus inside the function of x squared, if the number is greater than 0, it moves to the left. If it's less than 0, it moves to the right. In other words, positives move to the left, negatives move to the right. That's really important to write down because that's different than our normal thinking. When we have this number on the outside, positives move up and negatives move down. Let's look at one more example. We're going to graph this one. This has something inside and outside, so it's going to move from side to side and up or down. So our x-coordinate of our parabola is going to be 2, because when we go x minus 2 equals 0, then x equals 2. So we're going to start with the number 2 as our vertex for our x's. So let's choose a couple numbers less than 2 and a couple numbers greater than 2. And another thing we can see is this -1 means that our y is going to be -1. So our complete vertex in this one is going to be 2, -1. So when you look at a function, you can tell its vertex just by the numbers that you see. If you do not have anything here, then your y number is 0. Okay, in this example, I see 3 things going on. I see a multiplier, I see a number inside our function, and a constant outside our function. This -2 means that the graph is going to be wider than normal. The -3 means that it's going to move to the right 3 places, and the +5 means it's going to move up 5 places. And our vertex is 3, 5. And our line of symmetry will be at x equals 3 because our x coordinate is going to be 3. So let's go ahead and make a table of pairs for this. Remember, 3 was our x coordinate for our vertex, so we chose 1, 2, and 4, 5 after 3. And you just go through and plug in your numbers and solve. We have a lot of 3s. This type of quadratic function is sometimes called the vertex form or the graphing form because it displays all of this information. And it displays it exactly in the order you need it in. So let's look at this one. We'll quickly go through this one with the fractions. Notice our vertex is -7, 9. And our line of symmetry is going to be at -7. It's going to open down because this is a negative. And it's going to be flatter than a normal or wider than an x squared because this number is a small number. Okay, go ahead and get started on your homework. It's number 1 through 35 odd.